All right, everyone. Welcome to our Shop Talk webinar series. Today's session is all about streamlining workflows with NC Simul. My name's Jake. I'm going to be your host for today, and I have a few quick housekeeping notes before we get started here. Today's webinar is going to be recorded, and you're going to receive this recording afterwards. We've also muted all the mics and turned off all the cameras to create the best user experience for everyone. But if you have any questions at all throughout this presentation, please feel free to use the Q&A portion or the chat function, and we'll be sure to answer your questions as soon as we can. Now, while we were creating this presentation, Chris, who is our NC Simul expert, he's on the call. We just noticed that there's so much information that we want to share with you. The easiest way for us to present all of that information to you was creating a presentation that Chris had then recorded, and Chris is live on this call right now to be able to answer any questions you have throughout the presentation. Plus, we'll also have a Q&A portion at the end of the presentation as well. So right now, I'm going to shoot it over to Chris's presentation here. And then throughout that presentation, if you have any questions, please use the chat function. Chris will be able to answer those questions, and we'll also answer questions live at the very end as well. So I'm going to start kicking this over to the presentation.
Hello, everyone, and thank you for taking the time to join me today. I am Christopher Parker, Senior Supervisor of Applications Engineering here at Hexagon. I've been with the NC Simul team coming up on 10 years now, and we are responsible for supporting the North America market, everything from new digital twins to support cases to on-site trainings and whatnot. Maybe some of you already know me, but if not, hopefully we'll get to meet soon. Here is our agenda for today. It's broken up into two major projects. The first will focus on a workflow from a Spree Edge into NC Simul and how to easily do that with multiple setups or operations. Then, once it's in NC Simul, I'll show you some special actions you can perform using the interactive commands. From there, we'll switch machines to show the new rest stock previews capability, which allows you to pre-calculate the remaining material at each tool sequence and then only simulate those that are actually the most important to you. That's focused basically on answering the question, why do I need to simulate the entire part again if I've only modified a portion of the code? And hopefully that'll speed up your overall workflow. So let's get started, and I'll show you first how NC Simul handles projects with multiple setups. In this example, the part is machined in two separate setups, as we said. We begin with one work holding configuration, then switch the fixturing before completing the remaining operations. While this demonstration focuses on changing the clamp specifically, the same exact workflow applies to any multi-setup process, such as machining on one side of a part, flipping it over, and finishing on the opposite side. Within this, today I'll demonstrate two different approaches. The first is going to use the standard interface, and it's actually the recommended workflow for most applications. In this example, I'm using a 3-axis Akuma machine. The part is initially secured with these 3 clamps, and during the first setup, I'll machine and tap several holes that will later be used to fasten the part directly to the fixture plate. Once those bolts are installed, the original clamps can be removed, allowing the remaining machining operations to be completed without any obstructions. This workflow creates 2 distinct machining setups, which will become 2 separate setup simulations phases also inside of NC Simul. When I launch the installed interface, NC Simul automatically detects that the CAM project contains those 2 setups and pre-configures the project. So in this example, NC Simul has already identified both machining setups. The first one has been labeled with -1, the second one labeled with -2. And at this point, I simply just have to rename the project to make each setup a little bit easier to identify once it gets to the other side. The first setup represents the machining operations while the part is held by the side clamps. And the second setup represents the operations after those clamps have been removed and the part has been secured using those fixture bolts. One of the advantages of working with multiple simulation phases in NC Simul is we can use the copy stock function. Copy stock transfers the finished stock condition from the first machining phase directly to the initial stock for the second machining phase. Or in other words, the result of setup 1 automatically becomes the starting material for setup 2. Even if your project contains multiple stock models, you'll simply add multiple copy stock functions wherever they're needed, and it carries everything all the way through. To export this project, I'll go through the normal workflow. First, I select the appropriate machine. Next, I verify that my work offset is correct before exporting so everything falls in the correct location. I confirm that my stock model, finished part model, and fixture models are all correct. In this example, NC Simul exports only the tools used in the first setup, so I'll force the cutter comp radius to 0. And after confirming the machine origins, I'll select the NC program associated with setup 1. I can then repeat the same process for setup 2. I'll choose the second machine configuration, verify the work offset, confirm the stock and part models, load the updated fixture configuration, verify the tool library and initialization settings, confirm the copy stock function, and finally select the second NC program. Now that everything's configured, I can send the project to NC Simul. And NC Simul will automatically create the project containing 2 independent simulation phases, one for each of the machining setups as we just defined. When the project opens, NC Simul doesn't necessarily know which machining phase you want to view first, so it displays the project level selection screen so you can choose yourself. Here we can clearly see both setups. The first includes the original side clamps. The second shows the clamps removed and replaced with the fixture bolts. So from here, I can either open them independently, validate their machining, and return to the project overview, or I can do them both at the same time. One of the biggest advantages of this workflow is that each setup can be validated separately, so we'll do it that way. This allows you to completely verify the first operation before moving on to the second. If you're interested in just validating the second setup, NC Simul can have automatically calculated the first simulation in the background and pass the finished stock forward, allowing you to begin working directly on the second operation without manually running both simulations or having to come up with your own rest stock part model for Op2. As soon as the copy stock function is executed, the completed machining results from the first setup are automatically applied to the stock model and location for the second setup. Now we're working with the actual state of the part as it exists after the first operation, allowing us to accurately validate the second setup. And to save even a little more time, I'll fast forward through the simulation. And as we do that, we can see a few rapid moves through the material, but there are no collisions, so everything is looking good. And that demonstrates the first workflow for handling multiple setups. Switching between simulation phases is as simple as selecting the desired setup. The holes created during the first operation are already present, and if needed, I can return to the simulation at any time. If a collision does occur, such as interference with the fixture underneath the part, for example, NC Simul detects it immediately and reports the issue. Now let's take a look at the second style of workflow. This approach is more intended for situations where everything is machined on the same machine and the only thing changing is the work. Interactive comments allow NC Simul to simulate the manual operations that occur during the machining process, but these comments are still ignored by the CNC control, so they have no effect on the machine itself, and you can leave the G-code as modified coming out of NC Simul directly to the machine, and it won't hurt anything. However, when NC Simul actually reads them, they trigger specific simulation events that we can either have pre-programmed or we can program independently or specifically. Now, inside my solid mill operation, I'll have an interactive comment that tells NC Simul exactly when to do that, when to remove the first fixture and replace it with the second. When we just exported through the interface, I don't need to do it that way anymore. I no longer need two setups and machining sequences. Instead, I'll remove the second sequence entirely and export everything as one continuous operation. The machining process itself remains exactly the same. The only difference is that instead of using one fixture, the project now contains both fixture configurations. The first represents the original clamping arrangement, and the second contains the M8 fixture bolts that secure the part after the clamps have been removed. None of my tools are changed. My initialization, as in work offsets, stay the same. The only thing I'll change is the NC program, so it all comes out in one. To do that, instead of selecting separate programs for each setup, I'll load the single complete NC program that was posted, which I did just before we hopped on today's webinar. Now, when NC Simul imports the project, it loads the entire NC program along with both fixturing configurations, meaning both sets of work holding are initially present in the simulation. Then the first thing we need to do is remove the second set at the beginning of the program so it doesn't interfere with the collision checking or end up generating false alarms during the first machining operations. Now let's look at what that looks like during the actual simulation. Everything remains synchronized with the NC program, giving you an accurate representation of what the operator will experience at the machine, and it allows you to validate all parts of the process, the complete process from start to finish using a single NC program and still accounting for anything that actually goes on the shop floor. Now to finish the validation, I'll fast forward through the remainder of the material removal here. There's a few rapid moves through material, and we detect a small number of collisions that should be reviewed, but overall the machining process looks correct, and the finished part is produced as expected. That wraps up the first project for the webinar here. We looked at kind of two different methods for handling multiple setups in the same project. The first method or approach used separate simulation processes, separate blue folders, with the copy stock function to transfer the machine stock from setup 1 to setup 2. And the second approach used the interactive comments to simulate all manual operations, allowing a single NC program to be output, and that accurately represents the fixture change that occurred during the machining. Both workflows are valid. They both provide accurate digital representations of the manufacturing process, and they both make it easier to validate complex multi-step jobs before they ever reach the actual machine. Okay, so returning to our agenda, the second part of this webinar is going to focus on the rest stock previews and the dive-in points that you can utilize based on those previews. While simulation is obviously essential, it can also become one of the biggest bottlenecks in the verification process, and we want you to get your parts out as quickly as possible. As those parts become more complex, waiting through roughing operations you've already verified just to check one finishing toolpath can ultimately end up wasting valuable time. So the point of this new feature is designed to give you faster feedback throughout programming so you can make decisions more quickly and spend less time waiting for your PC to calculate things. So let's open this project and let NC Simul decode the G-code as normal, your normal process that you've known all along. And this is in accordance with our classic three-step process, but is isolated to parsing through the G-code. This is still useful when initially analyzing the program for syntax errors, but in a case like this one that has really heavy machining, we want to create jumping in points to isolate those high-value machining processes for you. Instead of running a complete material removal simulation every time you want to see what's left on the part, NC Simul can generate a preview of the remaining stock in really a fraction of the time now. It allows you to basically answer questions like, did my roughing operation remove enough material? Is there still excess stock remaining? Do my finishing tools have consistent engagement everywhere? Things like that. All right, to do that, we'll generate the rest stock preview from this new icon up here. And while I'm up here, there's also associated tolerance settings located here, just in the drop-down to the left of that icon. Specifically for the rest stock, you can choose performance or a high-speed rendering, a balanced approach, slightly enhanced or highly enhanced higher accuracy. And the higher the quality, the more memory resources it'll require, so just bear that in mind as you choose. But the nicer the rest stock will look. Also remember, this is now GPU-based simulation. NC-Simul is the only G-code verification on the market that has this capability. It definitely doesn't replace the existing high-quality simulation module that we already have or will still use. We'll utilize that later for final processing, but it does give you the flexibility to navigate between operations without having to start at the top of the program each time and wait for the simulation to advance to the portion of the code that you're actually interested in watching or the portion of the code that you've just made a change in. Normally, it should run even quicker when you're also not utilizing Teams for screen sharing like we are. But as you can see, we already have stored material and jumping in points for the end of each sequence. And that's indicated by the rest stock icon, that gray L, next to each toolpath in the tree. So now when I click anywhere in the G-code, I will get a rough representation of what the removed material will look like starting at that point. And rather than waiting for a complete simulation, we're immediately able to visualize the remaining material and decide whether any additional changes are needed to be made. For everyday and first-time programming, this immediate feedback can save a significant amount of time, especially on really heavy parts, such as this with lots of rotational work. Now, let's pretend that you're confident about the machining up to and through sequence number 9, let's say. Or maybe you're a mold shop and you're outputting code one operation at a time from a CAM like WorkNC, for example, and you want to start verifying the next sequence with a representation of what's sitting out there on your machine right now. You simply scroll down to where you want to start, choose one or a collection of sequences with shift select, and then right click, and then choose simulate those selected operations. Instead of replaying every previous operation, Selective Simulation allows you to jump directly to the section you want to validate, and you can see the rest stock representation here. Then you can choose your simulation style, whether you want to continuously simulate it to the end, whether you want to stop on each error or warning message, each tool change, or a different condition, and then set a speed at which you want to watch. Once you hit play, you can see the green bars on the left fill in instantly, indicating our jumping in point, and then the simulation will start picking up from right there. At this point, we're now utilizing the traditional NC-Simul material removal engine again, which is no longer a quick representation, but the full-blown accurate material removal that you're used to. It allows us to verify all the machine motion, all the tool engagement, any material removal just like before, but starting with a stock estimate at any point just to get us to this point much quicker. Again, especially useful when making program revisions, testing optimized toolpaths, or validating any customer changes to the part that you may receive down the line. And to give you a little bit of a better idea, a typical flow might look like this. First, you make a programming change. Then you can come in here, you can generate a rest stock preview to verify the remaining material just above where you want to verify. You jump directly down to that operation with Selective Simulation. And then once you're satisfied with the result, you complete one final full machine verification that you don't have to watch, and then you release the NC program to the floor. Working like that, with that approach, speeds up the programming while maintaining, your full confidence in your finished program. There's really not much to it other than that. You simply have the option to simulate the whole process as before, or break it down into two processes, one to give a quick representation of the rest stock using the GPU simulation, and a second to come in and truly certify all the material removal as a finalization. So as this continues to run, I'll summarize again kind of what we covered today, and then I can turn it over to the Q&A portion right after that. But basically, we saw how to import multiple operations from Esprit Edge to NC Simul. That process works exactly the same for any of the other major CAM systems that we have a built interface for. And then once it was in NC Simul, we used some of the functions from within the G-code, like the copy stock and the clamp add and remove, to mimic actions performed by the machinist for a full picture of the full process. After that, we looked at this new feature, which can create intermediate stock models using the GPU simulation and allow you to simulate from the beginning of sequences that are partway through the program. All of this with the larger idea in mind that it'll save you time in your out-the-door process time while still utilizing NC Simul as part of that process. Overall here, NC Simul is going to transfer prove out from on machine to in programming room, freeing up the real machine to be in production, but it also removes any uncertainty of behaviors due to post discrepancies or hand edits that might make their way to the machine without you realizing. So here's my info. You can feel free to reach out to me directly or follow up with Jake after this, after the webinar, and I can answer any additional questions or show you how it works on a more specialized level one-on-one. But for now, I'll open the floor to any immediate questions you may have and field those as best I can.
Thanks, Chris, for that presentation. I have a handful of questions for Chris. If anyone on the call has any questions, though, feel free to drop them in the Q&A portion of this, and then I'll be able to filter those over to Chris for them. So, Chris, first question I have for you is, does it support turning?
So it's going to. It's going to support turning with NC Simul 2026.3, which is slated to come out right around mid-September or right around the same time we'll be at IMTS.
Perfect. Awesome. And this is a good plug. Hexagon will be at IMTS in September. So if you are going to IMTS, would love to see y'all at our booth in September. Chris, another question. Can I have more than 2 setups?
Absolutely. Yeah, there's no practical limitation to the 2. You can flip it as many times as you want. You can put it on as many different machines as you want. Just this example happened to have 2 different setups with 1 flip.
Perfect. And what happens if setup 1 changes after I've already verified setup 2?
I showed it very briefly, but you can basically just right-click on the setup 1 and ask it to recalculate automatically, or you can enter that setup specifically and then run the simulation again. And the way the copy stock function works is that it's completely dynamic. So if that setup 1 results in a different stock model, you don't have to import and export an existing or similar stock model. Again, it'll automatically use that copy stock function to carry the most recent code result through the process.
Perfect. And can setup 1 and setup 2, can they use completely different machines?
Yes. So as long as you have a different blue folder there, a different simulation process, then it can be any of the digital twins that you own and are working through on the shop floor.
All right. And do interactive comments get posted to the CNC?
Because they are comments, the real CNC won't actually read it. So you can leave it alone when you're done working through NC Simul, and then NC Simul knows what to do with it, but it won't get read by the actual machine. So there's nothing to worry about there.
Got it. Okay. And what other things can interactive comments simulate besides clamp changes?
Basically anything that the machinist or operator is doing manually. So if you have to manually load a tool or like a right angle head and you have to put that in, we can have NC Simul stop and then have that tool show up as if somebody was putting it in there. Also, if you're doing tailstock positioning by hand, so it's not part of the G code, which we can also simulate. But if it's just a hand done, we can have that show up in the right position, or really anything that you might stop the process on to either inspect or clean or anything like that.
Great. Okay, perfect. And how accurate is the rest stock preview?
So it is a more general representation, depending on which one of those quality settings that you use. So it's definitely accurate enough to provide a good jumping in point. But if you want to do the full simulation, that's why it's important to use our module that we had before, where you still click that simulation button, and then it's doing the true material removal rather than the representation. But it is close enough to give you a jumping in point that is going to save you a bunch of time if you're hopping around or making changes.
Got it. Okay, perfect. And no one's dropped any questions in the chat yet, so I'm going to ask one more and then I'll close this out. Is Selective Simulation still using real collision detection?
So it's a little bit different in that regard. So once you jump into Selective Simulation, NC Sim switches back to the traditional material removal. It's doing the collision detection at that point, but it's to get that representation of your jumping in point, it's not doing the same collision detection as it does when you hit that simulation button, which is kind of why we say it's important to still do either, but it allows you to kind of reduce your workflow time to get to that point.
Perfect. Awesome. Thank you, Chris. If anyone else has any questions after this, please feel free to reach out to both Chris or I, and we'll be able to take care of those questions for you. A couple things to wrap up with for today. We will be sending you a recording of this webinar afterwards, so keep on the lookout for that. We're also going to continue having more Shop Talk webinars throughout the year, so please be on the lookout for those. We'll be sending out email communication about those in the future. And also, like I mentioned earlier, we're going to be at IMTS. So if you plan to attend IMTS, please make sure you stop by our booth. It would be great to meet you in person. But if not, then we'll see you in the next Shop Talk webinar. So thank you, everyone. Enjoy the rest of your day, and we'll be in touch soon. Thanks, everyone.